In today's class, we are going to talk about ratio. Let's start by defining what is meant by a ratio. Ratio is the act of comparing like quantities such as weight, length, money, and other quantities like that. Ratio shows the relative size of one quantity to another. Ratio is usually denoted by this sign. This is the sign that is used to denote ratio. You understand? So let's have some practical mathematical concept on ratio. Let's say you are asked to take the ratio of m to n. Ratio of m to n. What is the ratio of m to n? The ratio of m to n can be expressed mathematically as m. This is the sign for ratio n. Do you understand? So, and when we're talking about ratio, we can also express this in fraction. You understand? So, to express this in fraction, the first quantity here will be on the numerator. Are you paying attention? The first quantity will be at the numerator, and while the second quantity will be at the denominator. So, ratio n is equals to m over n. Please, it is very, very important that you pay attention to this, okay? When you are expressing two quantities in ratio, the first quantity will be at the top, that is at the numerator, okay? While the second quantity will be at the denominator. Do you understand? Okay, let's take some work example on ratio. Now, a certain island contains 540 cats and 675 dogs. What is the ratio of cats to dog? A certain island contains 540 cats and 675 dogs. What is the ratio of cats to dog on this island? Now, pay attention. We have been informed in the question that the total numbers of cats on the island is what? 540 cats. So, cats. Oh, let me change this marker. For cats is 540, okay, in number. Are you paying attention? And for dogs is 675. For dogs is 675. Now, to express this in ratio, don't forget the law. The first quantity will be at the numerator, you understand? And the second quantity will be at the denominator of our fraction, okay? So the best way to solve this is to express it in fraction. If I'm to take the ratio of cats to dogs, let's first express in fraction, and then we are going to divide it to lowest terms. You understand? We are going to reduce the fraction to lowest term. Now let's go. For this, the first quantity is the cats. So I'm going to have 540. What happened to this marker today? 540 all over dogs. Dogs is what? 675 all over 675. Do you understand? Okay, now you can see we have 540 over 675. What can goes in 540 and 675? That is, you express this by 5. Divide 540 by 5. We are going to get 108. So for this, I'm going to have 108 all over. Divide 675 by 5. We are going to get 135. So for this, we are going to have 135. Okay, this fraction can still be reduced. What can we use to divide both the numerator and the denominator? Divide both by 9. We are going to have 12 over 15. So this divided by 9, that is 12 over. Oh, sorry, this is 12. 12 over 15. You know, if you divide 108 by 9, you are going to get 12. And for 135, you are going to get 15. You know, at this form, I divide this by 5, divided by 5, and I divide it by 5. Then I don't realize that I can also divide both the numerator and the denominator by 9. You understand? So I divide this by 9, and I divide this by what? 9. Do you understand? And for attention, if you don't know what is meant by numerator? Numerator is the upper part of our fraction. You understand? This is the numerator and this is the denominator. This is the numerator, and this is the denominator. denominator. Do you understand? Okay, now we have come to this point. This can still be reduced to lowest form. Look at this. What can goes in 12 and 15? You know that 4 times 3 will give us what? 12. And 5 times 3 will give us 15. You understand? So this implies that 3 can go in 12 and it can also go in 15. You understand? So 12 divided by 3, that is what? 4. And 12 divided by 15 divided by 3, that is 5. So this over 5. So we have expressed this in lowest term. So for this, the ratio of cats to dogs now is 4:5. You understand? The ratio of cats to dogs is 4:5. Do you understand? So that is what is meant by ratio. Ratio compares two similar quantities. You understand? It shows the relationship that exists between two quantities. That is, if one quantity increased by this amount, what will happen to the other quantity? That is what ratio tells us. You understand? So let's have another work example. Okay, the ratio of a boys to girls is 8:7. If there are 40 boys, how many girls are present in the class? To solve this question, okay, we are going to put the information related to the boys on one side and the information related to the girls in in another side. Do you understand? So for easy computation, just pay attention, okay? Now we are told that the ratio of the boys to girls is what? Ratio 7. Okay, ratio. Let's say this is boys, okay. We have girls on this side. Do you understand? So we want to put it in fraction, and also we want to put the information relating to boys on one side and the information relating to girls on the on another side, which is on the right hand side of this. So let me put fraction. Please just pay attention. You are going to understand. Okay. Now we are given that the ratio of boys to girls is what? 8:7. That is, boys is what? 8, because boys came first. Okay, so boys is what? 8, and girls is 7. Okay, 7. Do you understand? Now we are now told that if there are 40 boys, how many girls are present in the class? So there are 40 boys. Let me put that at the denominator. Now, how many girls are present in the class? We don't know the numbers of girls that are present in the class, and that is what we want to determine. You understand? So let us represent it as a letter. Okay, you can represent it as any letter. Let me put X. Okay, let's represent it as X. Now we can easily solve for the numbers of girls present in the class when there are 40 boys, because we can easily cross multiply. Okay, so for this we are going to have 40 we multiply 7 and X we multiply 8. Do you understand? So for this we are going to have 8 multiplied by X is what? 8x, which is equals to 40 multiplied by 7. Do you understand? Okay, now 8x is equals to, we can express 40 as what? 5 times 8. You understand? 8 times 5 multiplied by 7. Do you understand? So this 8 can cancel this 8. I'm very sure you understand what I did. You know, I don't want to make use of calculator here. Okay, I don't want to make use of calculator. You can do this without calculator. If you are given this in objective, you just solve it and get your answer quickly. So you move to the next question. So 8 divided by 8. This 8 will cancel this 8. So I'm left with what? X is equals to 5 times 7. 5 times 7 is what? 35. So X is equals to 35. Therefore, the numbers of boys that is present in the class is the numbers of girls that is present in the class when there are 40 boys is what? 35 girls. Do you understand? You know, we've been given that when there are 8 boys, there are 7 girls. That is what ratio tells us about. You understand? Now, the numbers of boys increase to 40. How many girls will be present in the class? That is it. So we express it in fraction. I pay attention. Then after that, we solve for the value of X, and we have made I've told you X is the total numbers of girls that are present when there are 40 boys, and now we got the value of X as what? 35. That means that when there are 40 boys, there are 35 girls in the class. Okay, let's move to another question. Grace can make 14 cakes in 6 hours. How many cakes can she make in 16 hours? Now, how do we solve the problem? Let us put it in fraction like we did for the previous question. Okay, now Grace can make 14 cakes in 6 hours. That's the first statement there. So for this, I'm going to have cake. Are you paying attention? Cake. And for this, I'm going to have hours. You understand? So let's put it in fraction. Now, we are told in the question that the numbers of cake that Grace can make in 6 hours is what? 14. So I'm going to have 14 cake. You can make it in 6 hours. Do you understand? Now the question now proceeds that how many cake can Grace make in 16 hours? So in 16 hours, how many cake will he make? Let us represent it as x. Do you understand? So we have formed this fraction now. The next step is that we cannot solve for the value of x. Do you understand? So to solve for the value of x, we have to what? Cross multiply. So for this, I'm going to have this, and this will multiply this. So x, 6 multiply x, that is what? 6. Let me just express this. 6 times x is equals to 14 times 16. Do you understand? Okay, 6x is equals to 14 times 16. 14 times 16 is 224. Do you understand? So divide both sides by 6. So x is equals to 224 divided by 6. That will give us 37. You understand? Approximately 37. You know, that is 224 divided by 6 is a recurring fraction. You understand? So it will give us 37.3333. But just approximate to 37. Okay. So the numbers of cake that Grace can make in 16 hours is 37 cake. Do you understand? So that is the solution to the question. You can see that this is very simple. Ratio is simple. So let's move on. Let's have another work example. The length and width of small rectangle is 9 inches and 8 inches respectively. The length of the large rectangle is 24 inches. If the length and the width of the two rectangles have the same ratio, what is the width of the large rectangle? Okay, now let's start by writing out the parameters that were given in the question. We are given that the length and the width of small rectangle is 9 inches and 8 inches respectively. Okay, let me put it. Small rectangle. The small rectangle has a length of 9 inches. Length is equals to 9 inches and width, let me just put it as W, okay? Width of 8 inches. Do you understand? 8 inches. Now, the big rectangle has the large rectangle. The large rectangle has a length of of 24 inches. Okay. Now we've been informed that both rectangle has the same ratio. Okay. Now, if they have the same ratio, what is the width of the large rectangle? That's what we are looking for. The width of the large rectangle. That's what we are looking for. Now we can put this in fraction. Okay. We can put it in fraction. Let's have small rectangle here. Small rectangle and large rectangle. You know, this is for easy computation. You understand? We can put this in fraction. Now, if you want to put it in fraction, don't forget the step. Just put something here. Put the fractional sign here. Now, let the length be at the numerator. Okay? Let the length of both rectangle be at the numerator. So let length be here. So the length of the small rectangle is what? 9 inches. The length of the small rectangle is 9 inches, and the length of the large rectangle is 24 inches. Okay? Now, the width of the small rectangle is what? 8 inches. So I'm going to have 8 here. And the width of the large rectangle is unknown. We don't know the width of the large rectangle, and that's what we are looking for. You understand? So let us represent it as maybe x. Okay? Now, we have changed this to fraction. So we can easily find the value of x to know the width of the large rectangle. Do you understand? Just equate this to this. Okay? So for this, we are going to have cross multiply. This 9 will multiply x, and this 8 will multiply 24. So I'm going to have 8. Okay, let's start. 9 multiplied by x is equals to 8 multiplied by 24. Do you understand? So 9 multiplied by x is what? 9x. So for this, we are going to have 9x. 9x is equals to 8 multiplied by 24. That is 192. Okay, 192. The next step is to divide both sides by coefficient of x, which is what? 9. Divide both sides by 9, that is this over 9, this over 9. So x is equals to 192 divided by 9, that is 64 divided by 3. Okay, 64 over 3. So that is the length of the large rectangle. I only put this in fraction. You can also express it in decimal. To express this in decimal, that is, just pull out your calculator, 64 divided by 3, that is 21.33. That is 21.33. Oh, sorry. I put the approximate sign here. That's not where it should be. It should be here. Okay, 21.33. You know, 64 over 3 is a recurring fraction. Okay, so if you will see your calculator, by the time you divide this 64 divided by 3, that is 21.33333. You understand? So I just approximate. I leave it at 2 decimal places. Do you understand? So that is the length of the large rectangle. The width of the large rectangle is 21.33 inch. Okay, or 21 inch. Okay, to whole numbers. You can leave it in whole number, 21 inch. Do you understand? The ratio of nickel, dimes, and quarters in a jar is 3:4:7 respectively. If there are a total of 112 coins in the jar, how many of them are nickel? Okay, now I want you to pay attention. Okay, this is a multi-step problem. Okay, so I need you to pay attention. Let's start by writing out the parameters that were given in the question. We are given that the ratio of nickel, dimes, and the ratio of nickel, dimes, and quartz is 3:4:7 respectively. Abi, so let me represent nickel. Let me represent nickel as N. Okay, nickel as N, and dimes as D. Are you paying attention? And quartz as Q. Okay, and quartz as Q. Now the ratio of nickel, the ratio that we are given is what? The ratio that we are given is 3:4:7. Okay. Now this means that the ratio of nickel is 3. Are you paying attention? You know that we are given that the ratio of nickel, dimes, and quarters in a jar is 3:4:7 respectively. That means that nickel has 3 as its own ratio. Okay, the individual ratio of nickel is 3. Are you paying attention? Now for dimes, the ratio of dimes is 4. Okay, please pay attention. And the ratio of quartz is 7. You understand? This means that if there are 3 nickels in the jar, there will be 4 dimes and 7 quartz and 7 quarters in the jar. Do you understand? So, and if there are 4 quarters in the, if there are 4 dimes in the jar, there will be 3 nickel and 7 quarters in the jar. Do you understand? So now we want to determine the numbers of nickel that is present in the jar. To determine the numbers of nickel that is present in the jar, the first step is to take the sum of all the ratio. You understand? So the total ratio, let me put it like that. The total ratio is equals to 3 plus 4 plus 7. Okay? 3 plus 4 is what? 7. 7 plus 7 is what? 14. So the total ratio is what? 14. Do you understand? Don't worry, I'm going to teach you 2 methods. You are going to choose the one that is very that you understood. Okay, you're going to choose the one that you understood. So to determine the numbers of nickel that is present in the jar, the numbers of nickel present in the jar, nickel is equals to the ratio of nickel, are you paying attention, all over the total ratio multiplied by the coin, the total coin. Let me put it like that, the total coin. Please, do you understand? To determine the nickel coin that is present in the jar, the ratio of nickel all over total ratio multiplied by total coin present in the jar. Do you understand? So the nickel is what? 3. So nickel is equals to, the ratio of nickel is what? 3. So I'm going to have 3 all over the total ratio. The total ratio is what? 14. So 3 all over 14 multiplied by the total coin. Don't forget that we've been given in the question that the total coin, the coin, is equals to 112. You understand? So this multiply 112. Please, do you understand how I got this? If you didn't understand, pay attention again. We have been given that the ratio of nickel to dimes and the quarters is what? 3:4:7. Okay? So, and I have this. So the first step, using this step, using the first method, I'm going to teach you another method. Okay? Using the first method, the first step is to sum up all your ratio. Okay? Now, you now take the ratio one by one. We are told to determine the total numbers of nickel coin that is present in the jar. Okay? And the ratio of nickel is what? 3. So you're going to use this formula. The ratio of nickel all over the total ratio multiplied by the total coin in the jar. Okay? Now, 14 here 1, 14 here 8. So I'm going to have nickel is equals to what? 3 multiplied by 8. What's the answer? 24. So there are 24 nickel coin. Okay? There are 24 nickel coin present in the jar. So now you can determine, though we are not asked to determine the numbers of dimes that is present in the jar, but I want to teach you. Okay? Now to determine the numbers of dimes coin that is present in the jar, you are still going to go with the same step. This is for nickel, don't forget. Now let's go for dimes. Dime is what? 4. So we are going to have dimes is equals to 4 all over the total ratio. Okay, let me express the formula. You are going to express the formula as this, okay? Dimes, ratio of dimes all over the total ratio multiplied by the total coin. You understand? Ratio dimes, the total numbers of dime coin that is present in the jar is equals to ratio of dimes all over the total ratio multiplied by the total coin. The ratio of dime is what? 4. Okay, so I'm going to have this 4 all over 14 multiplied by 4 over 14 multiplied by the total coin. The total coin is what? 112. Do you understand? So this here 1, this here 8. Okay, so the total dimes coins that is present in the jar is what? 4 times 8. Okay, 4 multiplied by 8. 4 multiplied by 8 is what? That is 32. You understand? So for this, I'm going to have 32. So the total numbers of dime coins that is present in the jar is 32. So you can do for quarters. Okay, do for quarters. Let me check if you get the answer. Do for quarters. All you have to do is that you change, that will be the numbers of dime quarters coins that is present in the jar will be 7 all over 14 multiplied by 112. Okay, you are going to get the total numbers of quarters coin that is present in the jar. Now let's use the second approach. Okay, let's use the second approach. For the second approach, we are given that the ratio of nickel, let me represent as N, the ratio of nickel to dimes, let me represent as D, and the quartz is Q, is what? That is 3:4:7. Okay, 3:4:7. The ratio of nickel is 3, that of dime is 4, and that of quartz is what? 7. Okay, now using in this approach, I'm going to have total here. You know, I want to express it in fraction like we did for question 2 and 3, like we did for the previous question. Okay, now the total here will be what? 14. Okay, that will be the total ratio. This is the ratio. Okay, ratio 3 plus 4 plus 7, that is what? 14. Now, okay, for let's put it in fraction. Now the total coin that is present in the jar is what? The total coin that is present in the jar is 112. So I'm going to have 112 here. Let the numbers of nickel coin that is present in the jar be N. Okay, let the numbers of dime coin that is present in the jar be D. Okay, and let the quarters coin that is present in the jar be Q. You understand? So N plus D plus Q must be equals to what? 112, because the total coin that is present in the jar is what? 112. Okay, now we are asked to determine the what? The numbers of nickel coin that is present in the jar. We can easily determine this. Just set this fraction equals to the total. This fraction 3/n equals to the total. You understand? Please pay attention. we are asked to determine the nickel coin. The nickel coin have what? This is the fraction of the nickel coin. That is 3 over n is equals to 14 over 12. So I'm going to have 3 over n is equals to 14 all over 12. Okay? Now, if you cross multiply, we are going to have n will multiply this 14 and 3 will multiply this 12 on 112. So I'm going to have 14 multiplied by n is equals to 112 multiplied by 3. Do you understand? So for this, I'm going to have n is equals to 112 multiplied by 3 all over 14. Just like dividing both sides by 14, you understand? 14 multiplied by n is what? 14n. So I divide both sides by 14. So this 14, we eliminate this 14. And this 14 here can give this. I'm going to have 8. Do you understand? So n is equals to 8 multiplied by 3. That is what? 24. So the total numbers of nickel coins that is present in the jar is what? 24 nickel coin. So that is it. Do you understand? Now let's go for another. If I'm told to determine the numbers of dime coin that is present in the jar, I'm just going to set the fraction of dime coin is equals to the total fraction. So let's go. For this, I'm going to have 4 over d is equals to 14 all over 112. Do you understand? So if you cross multiply, you're going to have 14d is equals to 4 multiplied by 112. So 14d divide both sides by 14, okay? All over 14. Do you understand? This 14 will eliminate this 14. So this 14 here 1, 14 here 8. So for this, I'm going to have d is equals to 8 multiplied by 4. D is equals to what? 32. Do you understand? So there are 32 dime coins in the jar. Do you understand? So we can determine for quarters also. You know, in the first method, I didn't show you the how to determine for quarters. But if you get it right now, you're going to know. Let's check. Just set the fraction of the quarters coins to the total fraction. Do you understand? Set the fraction of the total coins is equals to the total fraction. So I'm going to have for this, I'm going to have 7 all over q is equals to 14 all over what? 112. Now, cross multiply. We are going to have q, we multiply what? 14. And this 12, we multiply what? We multiply 7. 112, we multiply 7. So I'm going to have 12 multiplied by, 14 multiplied by q is equals to 7 multiplied by 12. Okay, so 14q is equals to 112 multiplied by 7. Now divide both sides by 14. For this, I'm going to have 14. Now this 14 will eliminate this 14, so I'm left with q at the left hand side of this equation. This 14 will multiply, we eliminate this 112, so I'm left with 8. 8 multiplied by 7. 7 is equals to what? 56. That means that there are 56 quarters coin in the jar. Do you understand? So I want to do something now. I solved this using the first step. That's the first method, and I solved this using this is the second method. Now I want to do something. Drop the approach that you find most interesting in the comment box. Okay, I want to know the approach that you find most interesting, that you find that you understood better. You understand? Okay, let's proceed to the next question.
To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.